Yeah, see, बच्चों, that's a question from binomial, series of binomial, but really a good question here. It needs a different approach, though the statement, the rule or the result, whatever you call it, I'm going to use here. I have already discussed it in one of the previous question. Okay, if you remember, I discussed this property, Bahubali property. So those who tried and who couldn't solve it and know this property and has been following this series very regularly, they should pause this video here, apply this property and then solve it, because once we know what is Bahubali property, so if you have already seen that this property is application in one of my previous video, its solution, then you should pause this video here and try this question on your own and get the answer, bacho. Okay, and for those who are new, so let's proceed. So see, I will say let this series be S, which is when k goes from 0 to n ck times sine of kx into cos of n minus k times x. Now what is Bahubali property? So Bahubali property simply says, see, that's a property which we very commonly use in definite integration, which is integral a to b fx dx is integral a to b f of a plus b minus x dx. Okay, the most important property I say in definite integral. Similarly we can use this property in summation also. So it says that add instead of like the variable of the summation, which is k, replace k by sum of the lower limit and the upper limit of k, n plus 0, which is n minus k. So where and the value will remain same. So summation going from k goes from 0 to n c n minus k, so that's same as n c k, isn't that, into sine of k to be replaced by n minus k times x, and when you replace here k by n minus k, you get kx, bacho. The position gets reversed. And now see, again I will say, those who are following these videos very regularly, they know what is the next step, and that is add both the summation. Here also whenever we use Bahubali property in definite integration, that's what we do, we add both the integrals, the given and one which you get after applying the property. So add 1 and 2, what do we get? We get this imply 2 times s is, as I said, this is same as nck. So take it common, so summation k goes from 0 to n ck is common, then you have sine of kx cos of n minus kx plus cos of kx sine of n minus k times x, bacho, isn't that? Now what is it? So all of us know that's the identity sin a cos b plus cos a sin b. So I write it as k goes from 0 to n ck sine a plus b and x plus kx minus kx, so that gets cancelled. Now sine and x, there's no variable of summation involved, there's no k here, so that's a constant, so that's as good as a constant. So 2s is, take it out of the summation sign, and then you have this value, and all of us know what's the value of sum of all the binomial coefficient, that is 2 raised to the power n. So this imply s is sine of nx into 2 raised to the power n by 2. So the answer is 2 raised power n minus 1 into sine of nx, bacho. That's the answer here. Okay, so that was the question based on Bahubali property for summation, bacho.